Welcome, everyone. I hope you've had a fantastic day at Dash. This is our last session of the day before partying and drinking it up or whatever, except for these guys up in front, who I think are going to play a drinking game with whatever Bill says. Yeah. That said, welcome. I'm Jason Yee. I'm a staff technical evangelist at Datadog. I've been hosting this room and moderating a bunch of these panels. With me today, I've got a bunch of amazing experts on the subject at hand of architecting for reliability. So right next to me, Robbie Gladman from Charter Communications, principal architect there. Robbie is obsessed with making sure that everybody can see what's going on and improve their systems and keep them up and running. When he's not doing that, though, he likes to get outside, which is very important, especially when you're an engineer and behind a computer all the time. So he likes to get outside with his daughters, play some beach volleyball. Right next to him is Bill. Bill Heinlein is from United, with the United crew up here in the front. So glad for them all to be here, but he is the director of QA and release management and also responsible for observability. And basically, I don't know what you all do, because it sounds like Bill's doing everything.
Entourage. They just come with me.
All right. So yeah.
These are the people that actually work. I just point.
Bill also has a great fact, though. He volunteers for a group that works with homeless and runaway youth. So that's his fun fact, which not only fun, but like really impressive. So thanks for the work you do there.
Thank you.
And at the very end, Ashley Miller is VP of Engineering at Datadog for our application infrastructure. She lives here in New York, where our headquarters are. She's been working at startups, you said, since 2007. So pretty impressive. And you've got a cute dog with messed up ears?
She's got bad ears.
Bad ears.
Bad
So-
ears or bat ears?
Bat.
You have a Frenchie?
I don't.
Oh.
She's a mutt.
Just checking.
So normally there's the obligatory, you have to show us the photo. I don't have it on slides, so afterward you should all queue up and make her show you pictures of her pup. That said, we'll kick it off with the topic at hand, architecting for reliability, right? Like how many of you all are engineers? You're building things. I think that's most everybody. Yeah, we got some ish people, like we don't really know, but so I guess to kick off my question to the group, right? We're thinking about reliability. As you do that, as you're thinking of your systems, whether you're building them or maintaining them, what's one principle that you try to keep as your North Star for reliability?
Yeah, I'll start with this one. Simplicity is always so important when you're designing at the big picture, the architecture level. Also, when you get more into the weeds and into the code level as well. Software is very open-ended. You can do anything. There's no one right answer. There's better answers, right? But there's a lot of ways to do things, and so it's very easy to overcomplicate things while you're working through. An example of this recently is we started doing a blue-green approach for our microservices environment, using a DNS flip to move traffic over. We sort of graduated from that. We use the ALB and do a more of a canary approach, so it's like a slower rollout. Allows us some validation. But then, as we're sort of wrapping up some of our modernization, we found some things that were not quite yet modernized, and one of them being a Lambda function that served to, when we would get voicemail audio files, it would transcribe those, and those get passed along so that ultimately people could get those transcriptions, in the app and so forth. And we were trying to figure out, so with our microservices, we have this canary approach. We can roll forward, roll backwards. We have a single place to do that. It's easy to do. But then we have these other things that start appearing outside of that. And how do we manage those? If there's change dependencies within what's happening in that Lambda function, because it does make a call into the microservices cluster when it's done. How do we manage and keep those things in sync together as we're going through? Like first ideas were like, oh, we could do maybe two lambdas. We have a blue lambda and a green lambda. But then, well, do we need then two S3 buckets? A blue one and a green one, but then how do we manage? How do we flip? Terraform makes these things easy to manage, but how do we manage, the in sync with the rest of the cluster rollouts? And ultimately, it sort of occurred to us, oh, we can actually move all that application logic into the cluster itself with sort of the rest of the application logic. And that way, our Lambda becomes very simple. It just forwards the message along that something was put into an S3 bucket. And the original functionality, that transcription, is now within the cluster itself. So we can also scale easily. We have all those things. And it actually made that functionality easier because when we took, that was made by the same devs who put all the microservices, which use the same sort of configuration paradigms, which relied on sidecars and stuff like that we have within our cluster to make that available. But you don't have that in the Lambda. So it took extra work to make that run in the Lambda, but in the end, moving it back to the microservices actually made it easier, and it was less to do, and it sort of deploys along with everything else. And so sort of finding ways to make things cleaner, simpler, really helps manage the complexity of what's going on.
Is part of that predictability? Like now you know how it's going to work because it works like everything else?
The automation has definitely helped because when we use the automation, we create the exact same thing in every environment. And it took us a while, but I guess about a year and a half ago, we started. Every 2 weeks we deploy and we rebuild from scratch with the exact same automation from lower environments to upper environments. And the consistency between environments was very tough when we had people who had to manually configure things. But once that made it into automation, that was like a big game changer, and getting the results we expect, when we get to the prod environment.
I'd say from my perspective, I think people spend a lot of time thinking about how do I engineer an environment to be resilient, to be reliable, and get really complex solutions in and forget the little things, like building an application, for example, that can live on its own and be agnostic as to where it lives and not have to have human intervention when something does occur, right? Not having even not having to fire automation to restart web services, for example, if you lose a database or if you fail to another region or things like that. That pull the rug out from under it and it comes back, I think gets people more than they realize. And I think with data from Datadog and trends, I think that'll be something interesting that we look at to try to identify those sorts of things. But it's these little things, or little things like, and the folks that are here with me from United will probably laugh at my examples because they're things we tend to relive, but we're heavy messaging, right? And thinking about how you deal with the unexpected, again, back to resiliency. And you can spend literally billions of dollars on DR and making redundancy and all of that, but if the app can't kind of self-correct when the environment changes unexpectedly, then all that stuff isn't going to help you, and this stuff probably has a greater impact on your overall reliability anyway.
Yeah. We've actually had 2 instances where we learned that by accident, where we had the client libraries when something went down, they never actually moved over to any of the other whatever became the next primary or to another replica. One with our on-prem stack we use Hadoop, the Hive Metastore is backed by MySQL. We found a plugin to do active-active. Mm-hmm. So we have multiple MySQL instances. They're all active. They all share information. Makes failover really simple for the server side, and that did work appropriately, filling over between instances. But some of the other client libraries and other apps didn't actually fill over, and we didn't know that until we had it actually stopped working. We had to restart it. Yeah. And we had a tougher issue within our microservices environment where our Redis node would go away. It doesn't happen very often, but when it did, all the services connected to it never reconnected to the service. And that was really tough to figure out. And actually, we had people who worked on that for a very long time to figure out how to actually make that happen, because that doesn't always happen out of the box.
Yeah.
I want to go back to something that you said, Robbie, because we were talking about simplicity, and then you went from microservices, dependencies, and then you mentioned sidecars, and it sounds like starting simply, but then it seems like it very quickly just escalates back into complexity. I'm curious, how do you actually manage that, right? how do you define simplicity around a microservice and ensure that as you have dozens or start to get hundreds or thousands of microservices, that it doesn't just devolve into complexity again?
Yeah. I think it's important to keep the appropriate functionality together, sort of understanding the appropriate role and what makes sense to put together. With some of our microservices, we've rolled out a GraphQL layer across all of our services, which makes it easier for our front-end applications because they can then query for whatever data they need. We don't actually have to implement specific APIs for each of those particular requests. But when you sort of mentioned the appropriately consolidating things, our original services behind that were meant to aggregate a bunch of information and provide a whole response back. But as we move forward, it makes more sense we actually need to rewrite those to provide more smaller pieces of functionality that's a little more reusable, because that actually matches better to how GraphQL expresses information as opposed to the way we previously did things. And ultimately, this requires extra work and extra gathering information to return that larger response when we only need a little piece of that to be more performant and more quick. More easier.
Yeah, like complexity is craft, right?
Yeah.
Like things, if it's alive and you keep like rewriting it and doing it, like you're getting rid of stuff, right?
Yeah.
And you're able to say, this is what we need, this is what's useful, and that's like much easier to monitor and understand what's going on, and like sort of have some faith that if you show up, like it's probably in use, like it's an active and living thing. Is that something that you guys think about? Like when you were talking about the making sure you're able to handle like environment changes, like how do you test it? How do you make sure that that's happening?
I mean, chaos.
Yeah.
I mean, I think you, unfortunately, for the things that I've talked about, you get the opportunity, and I think we could all say this, you get the opportunity to test those, unfortunately, on a regular basis. Services fail, nodes fail over, regions go away, like all of those things happen. And so you get to test them whether you plan to or not, right?
Oh, exactly.
So,
I was like, why did this latency spike? Oh,
oh
yeah.
yeah, look at that. Yeah.
Right.
Yeah, I mean, you build whole systems based upon certain assumptions, but you really need to challenge those assumptions, and chaos engineering is a great way to do so, because you'll discover things like if we had done chaos testing on those things that we thought would fail over appropriately, we would have known ahead of time that those clients aren't actually appropriately configured to fail over, right? And that would have saved that happening in that sort of fire drill that goes along with doing the production.
Yeah, and just those little things, like you do chaos testing, you fail over, and then you realize that you have a load imbalance in part of your environment or things like that, and you don't have to wait and find it in the middle of an actual crisis. So,
yeah, sometimes doing those things at scale is important too, because on a smaller scale, you get a different result than when you have that sort of production level traffic going through. Because that's a little harder to rebalance things and for things to come back up, or if there's data to move around. It's definitely a lot harder when you get to the larger volumes.
Yeah, there's always the one database where you're like, this doesn't work the same way. We also make lots of use of game days. Like that's what we like. Take a service, what can go wrong, you run through it, and then you sort of at the end have your punch list of things to change. It's really like, it makes like your changes super targeted.
I'd say the other thing from an observability perspective, I think that you've got to think about the full picture. I think, and we're just as guilty of this, you tend to wrap things that you know about up in all sorts of monitoring and tracing, and then you forget the big picture, and that becomes a vicious cycle. You've got all of these things monitored, but then there's something else, and the next thing you know, you're saying, I thought we had that monitored, and you don't. So these are all, I think, really simple things that you can do to have big effects on reliability and resiliency without, talking about the billions you have to spend on things like DR or replica environments, that sort of thing.
I was going to add on that you really have to iterate on the monitors that you do have and what you do collect. Because we've had this many a times that we have issues that happen, and everything can be green, everything can be happy, everything says it's working, but users can't actually use the system. And it's
up.
Yeah, like all the processes are up. They're responding to health checks. It's great. But you need to sometimes you have to go a little further to measure and so, I mean, if you can measure from the user perspective or your client perspective of what they're doing, you can actually do more of a sort of end-to-end test to sort of see, because I will hit all the pieces and do a little more complex, and our service is just up. We make extensive use of custom metrics for that. We've done it like on-prem with, I think we had monitoring that would run Hive queries through all the different endpoints that someone could actually submit a query. And it would do it, every couple of minutes, record the time, and send it as a custom metric. Because we had a period where our users would be complaining that they can't run queries, or they start the CLI and nothing's happening and they don't understand why. And so having this running, this would alert us as it's happening. It makes it really easy to start looking for other indicators of what's going on to help solve that problem.
I want to come back to something that Bill said. You mentioned, monitoring the things you know about, and then you often get services or things that get overlooked. Curious, what solutions have you put in place or processes to ensure that everything has monitoring and observability?
So so we're kicking off sort of a new observability program. We have done a lot of work over the years. I mean, that's what these folks sitting in front of me do, right? They're the folks who make all that happen. But we are putting more emphasis than ever on the idea of observability because, we're growing, right? I mean, you don't hear a lot about businesses growing, but we just bought 250 aircraft that we start taking delivery on. We'll have more than 1,200 aircraft in our fleet, and our window for recovery and incidents is going to be even smaller, right? And when that recovery doesn't happen, then unfortunately my friends here and I wind up as write-ups in the New York Times. That happened to us quite a bit, unfortunately, during our merger with Continental, and that's a tough performance review to get a write-up in the New York Times, but that drives it, right? That's the importance of making sure that we're able to get people where they need to go on time with their luggage is a very fundamental thing that can go wrong very quickly if we have an IT issue, right? Yeah. And at the scale we're operating, there can be no stone left unturned. So we're grouping everything into what we're calling an ecosystem, and we'll take basically those things that are key business capabilities like check-in or wait and balance or flight planning or whatever, and make sure that everything that's part of that component gets the right instrumentation, has the right visibility into it, so that we're good to go and we feel better about things.
I'd say it's a very much of a shift left approach, right? You need to be thinking about it as in the beginning to make sure that, because oftentimes previously, right, developers never have to worry about how does someone make sure that their service is working appropriately.
Yep.
And so that's something that they have to be, sort of move it that, you start actually at the big picture. How do we know that all these components through this flow that's required for this thing to happen are working appropriately? And as you have complex data flows, or if you have event-driven stuff across many things, how do you know that that's making it all the way through? And that's really tough. For some of our stream processing, we've built our own tracking and monitoring as events go through our real-time pipelines. And that's really helped us understand how any lags and how long that lag is or how late that data is arriving. But some of those pipelines support operations teams. Operations teams can't understand what's happening if the data is not in the system for them to actually show them what's going on.
Yeah.
Yeah, what you're all describing, and I think a lot of us operate in, is like this highly distributed system where there's a lot of latency, intentionally. You don't have an action and then something happens and it comes back and it's all synchronous. There's a lot that gets kicked off, you're running pipelines for Datadog. You send us a metric, a lot happens, and then you're able to see it, and we want that to be very low latency. And so things like APM have been really helpful for us to see things you haven't necessarily have metrics attached to. You can see okay, this service is erring in the middle. And I think trying to make each piece of those as simple as possible has been really helpful. Like, bound your caches, hard limits are good. Because then when things like blow up, you're very clear, like, this is what's wrong, right? Where you start to shed load rather than like randomly ooming, which becomes very strange, right? The same thing is like one thing is much easier to think about than two things. And don't split unless you have to, or there's like a very clear reason, like your sharding strategy doesn't work anymore, or this is more than a box can handle and AWS doesn't have something. Like, these are kinds of things that like we've like all experienced. You're like, oh, this workload isn't gonna be a server anymore. Like, let's make it into two applications, like an indexing and then the writing side. But all of that stuff starts in like the small. And I'm curious for you guys, like, are you thinking more systemically about, the environment being predictable, like,
Yes.
or focusing on the small things? Like, where do you find you get the most bang?
I think the most bang is going to come for us from being predictable, right? Because things that happen in the technology space, even at our current scale, but when you think about the scale and the size that will be in a few months, things happen very quickly, and there's suddenly a lot of angry people, right? I mean,
that's like your best alarm.
right.
It's like the phone lines have 2-hour waits.
If I walk into an airport and the lobby is full,
you pull out your laptop.
I look at my phone. And that's a problem, right?
Yeah.
And those things can happen in an instant, right? I mean, we fly just over 1 million or 500,000 people a day, and they all got to get somewhere, and they all tend to come to an airport and hang out until we take them somewhere, and they tend to stick around if the systems aren't working. But having the predictability to see that something's starting to go south and be able to automate it and react so we don't have the impact, but then go fix that is much better than, say, stopping. I mean, there are some systems that if they're down, then we ground the airline.
Yeah.
Right? We don't board planes. We don't.
So you're
dispatch
anti
planes.
like hard limits. You want a system to kind of degrade.
Yeah.
Oh, nice. I was looking for controversy. We found it. Where do you weigh on this, sir?
I'm with Bill on this one.
Okay.
Yeah, to rather have things, because when things slowly degrade, you can give it a little more time, as opposed to if it's entirely down completely, it's a much bigger impact than a poor experience is not as bad as unable to do something.
Yeah.
And there are things that aren't necessarily degrading, but are problems that, I mean, we had one a couple of weeks or a month or ish ago where we had one of our key databases crash. We had a physical hardware problem. This was an on-prem thing. We had a physical hardware problem. They were having such a challenge to restore that we've stood up another physical box quickly. They configured it, did great work. They forgot there wasn't multipathing turned on. So we had a single path. And I promise you, if my friends here were to go back and look through the systems logs, that there's probably a Veritas repeated event saying something like you're single pathed on this volume or something along those lines. And that would have been a beautiful golden signal for us to know about, because that would be a perfect, oh crap, I better fix that. That's going to get real ugly. And it did, because we lost the primary path and we were back in an outage again, right? And so those are examples of things where it's like, that's just a simple thing that if you fixed it, it'd be fix it and walk away and everybody be the wiser. But if you don't, then,
If you haven't monitored that thing, you don't know.
Yeah, and then it takes you down.
Yep.
So.
That's an argument for automation to set those things up,
Yes.
because there's so many little things that
Agreed.
are critical to getting them right so that you can actually get back up and running.
Yep, totally agree.
So Bill, you mentioned something, you repeated the word dependability, right? And we've been talking a bit about repeatability. Robbie, you and I were chatting earlier before Dash about something that you've worked on to basically help a bit on the back end, on the debugging and finding issues, because oftentimes I feel like the issues we face are ephemeral. Like they come up, something goes down, and you're like, I don't know what that was. I saw the metrics behind it. I can kind of deduce. Tell us a little bit more about that, because I think it's super fascinating.
Yeah, our microservices, we serve a couple major clients where we have customers accessing their accounts, managing their accounts, and so forth. Behind our microservices, there's like 90 different backend systems that we integrate with and pull information from in order to expose that to customers. The difficult part is that's 90 other systems that are in change, they're in flux, they're updating things. They're all, how well they implement their own contracts that they give to us sort of varies. The charter now is a single company, and we have most things consolidated post our last merger. But there's still a lot of variation between customer accounts based upon where they were and kind of what market they're in, what things they have available to them. So we've had a lot of our times the issues that are where we have errors in our service. APM can show us, where across all the calls in the entire flame graph, what failed. And we can see that in the logs, we see what the error was, but what particularly caused that error is the tough part. So one thing we've been working on is being able to capture all the request response data that's between all of our microservices, because with that, we actually are able to replay a request that went into a service and caused an error. We can inject all the responses. So same service, deployed in an isolated environment, doesn't know any difference. But now we're able to reproduce what's happening in production in an isolated environment. We have ideas of how to get a bugger attached, so we can actually have developers actually step through and understand what was returned from such service for. A lot of issues are user account specific. So yeah, they're definitely, they come and go. You can look at them, you can't find them after the fact unless you have what was returned from these various services. You can actually understand what's going on.
Does that also include like external services and you just mock the response? Mm-hmm. Nice.
Repeat the question so I stay on track.
Yeah, I mean, I was just, so Robbie built a system, but I'm curious, how do you do that at United when you face an issue? Do you have a way to basically go back and try to, how do you debug these issues, especially when systems are very ephemeral and they go away? And so oftentimes you feel like you're chasing a ghost, right? Like something went down, it comes back up, it's working now. I can see the metrics of something looks wrong, but how do you pinpoint that when things are changing?
I would say that APM has saved our life over the years.
Yeah.
Our ability to discover when things happen and pinpoint and focus, when we have these large scale problems and we have 200 plus people on a call, it's hard to focus people. And I had the luxury of having that role of focusing those people for quite a while. And I and this gang in front of me spend a lot of time on call saying, I'm seeing this and I'm seeing that, right? And just being able to find anomalies quickly that you may know nothing about the application or the underlying environment, but you can see something's broken, right? The database is running hot, it seems to be running hot on a table scan, hey, DBA, can you look at that? Right, just those little things were killing us before, but now APM has saved our life in that case. So another plug for good APM and good instrumentation.
Yeah, to add on to that, we've had several instances where we have odd issues, and usually we can resolve the issue by removing a node from the cluster, adding one back, or doing some other things. But to understand why the issue happened to begin with is a tough part.
Yeah.
And that's why it's important that you have a good observability platform and collect all the things you can, because by default, not everything is collected with the out-of-the-box configuration when you deploy to Kubernetes. So you actually have to go in and make sure all the things you want and they're actually using are actually being collected. Because there's been times we've had issues with CPU load where we had a single node in the cluster had a high CPU load, wasn't anything that stood out in terms of what was running on that node or what the services were doing. But upon digging around, there was one metric that alluded to there was an I/O issue with a disk on the underlying EC2 instance. Because it said it was spending 1,000% of its time running the disk. Now, none of the processes were writing any more information to disk than they were usually doing because we have all those metrics.
Right.
And ultimately, removing that node and having it replaced in the cluster would resolve the issue. But how that issue, being able to find that root cause is really important. Having all that data, they would go back and actually dig through it. It makes a big difference.
We used to call that server hokey pokey. This one, no, pull it in, pull it out.
Turn it on, turn it off.
Turn it on, turn it off.
Yeah, for us, like we've had like a service that was, it just would have spikes in memory usage. And like, what is going on here? And then finally, we like turned on profiling, which is, something newer. And we're like, okay, we can see what's happening. Like actually within like the Go routines, there was like an edge case that would get hit, especially if it were a longer running, because these servers are deploying all the time, so like normally things are like short-lived, so you don't hit this edge case that often. It really happens at like 2 a.m, and like no one quite was able to see what was going on, and then turning on profiling, you're like, I see. This is where like it's not garbage collecting correctly, so now it ooms, and that accumulates over time, and that's why it was like so unpredictable and inconsistent. So yeah, having the right tools can take something that was really frustrating and laborious and really like a ghost, and you can pinpoint it much more effectively. I think we saw that with APM, and now profiling is similarly magical.
So I think one of the challenges with reliability, as we've been talking about these and like having these issues that are hard to debug, is everybody sees when something's out, right? Like you have angry flyers, you have angry customers. And so I feel like the measurement for reliability is always like, how do you measure the absence of a thing, right? Like as you're leading reliability efforts, how do you measure that?
I mean, we use a lot of custom metrics to gather information in various places that's not otherwise built into the data already collected by Datadog. So that sort of helps identify the sort of external experience, or what people actually see in terms of when they're using our systems or hitting our APIs and so forth. And based upon that, we have SLOs that we create to help us sort of track when things are working and not working.
So essentially you're saying you have an SLO that captures the ideal user experience, and you're just measuring as much as we're trying to get as many customers in that ideal experience as possible. Okay.
For us, I mean, we look at all of these business capabilities, like purchasing a ticket. We know how long it takes. We know all sorts of cool data about the channels and where people buy tickets and all that. But then there are other metrics like, are there other business processes that have a dramatic impact on our operations reliability, like boarding, for example? If our gate reader system goes down, then, knock on wood, something. Yeah. Sorry,
We're not
Doug.
fine today.
Sorry, Doug. When we have a problem there, that will take our NPS score, our Net Promoter Score. That everybody that flies United, you get a survey. We take those very seriously. That gives us an NPS score. And if we have a technology problem that causes your flight to be delayed, that's a giant impact on NPS. And so we know which of these business processes have a direct impact on NPS. And so, that sort of decides how we prioritize them and all of that, right? So, and we use a lot of metrics to get there, right?
Yeah, so what does that look like when you track back, right? NPS starts dropping, something's wrong, but NPS obviously isn't like a metric out of a server or an application that says like, there's increased latency here, and this is the cause. So how do you tie those two together?
Well, I mean, we can see trends in technology. Like if we track by a business capability, we track basic metrics like uptime and when it's easy to see when we have a problem with a particular business capability and its reliability, it tracked to NPS, right? But we also have customer sentiment. We have some really cool tools that scan social media and do all of this cool stuff that say people hate United right now,
Okay.
or people love United right now, which is obviously more common. But anyway, but we can tie those back to events, right? When we have an event going on, that sentiment changes, right? And we can tell when we have longer, more systemic problems like onboard Wi-Fi. That is an incredibly complex thing. People don't think about the fact that they're watching Netflix on a plane, but what we've done is take your couch off the living room and put it 35,000 feet in the air, and then get a signal that we're shooting, from, I don't know, how many miles up, right? It's incredibly complex to do that reliable, but when people don't have it, they lose their minds. Myself included. I mean, there was a time when we got on planes and the door closed, you're like, quiet. No phone, no email, no nothing. I'm just gonna sit here. And now people can't live without it. But those metrics, we see that sentiment drop when we have problems with some of our Wi-Fi providers, for example, right? Or that sort of thing. So it's really easy to tie. I mean, it's not immediate on NPS, but it can be on sentiment.
Yeah. I think it's one thing for us to remember too, right? Like as we talk about reliability, it is that thing, like the last United flight I was on, I was like, I get free messaging, so I'm chatting with my partner, and I'm downloading some Docker images. I'm like, this was not possible, like even a few years ago. So as we think of reliability, sometimes I guess it is a good grounding to be like, we are way further than we used to be,
but
even when things are broken.
It doesn't change. That's more of just a funny thing. This Wi-Fi was not possible 10 years ago, and now it's like live or die if we don't have it.
Yeah.
But yeah.
Yeah, and I think you guys are running your own technology stacks. For us, like we have clients, obviously, like you guys, and so like for one, Datadog we use it to monitor ourselves. So like, you have 1,500 engineers who are like, this is a little slow. In addition to lots of monitors, so that like using your own thing, I think is incredibly helpful. And then the other thing is beyond just monitoring, like holistically, you start to see that problems happen not just for one, but a customer or a type of customer or maybe a product line, and having like appropriate segmentation in your metrics so that you can identify like, oh, this customer is actually starting to like send UUIDs. Maybe they don't want to do that. This is something we should reach out to them and let them know they're doing. So like, thinking about like the metrics you have, like we've talked about from the customer perspective is a big one. You have sort of these top line, this is what people are experiencing, and then sort of what I think of as like sentinel things, which are if something is wrong that we haven't specifically monitored for, it will show up in this metric, right? Like latency on like the classic is you start to see like requests queue at the web layer. You're like, okay, something is wrong. And you can start to trace back from there. But for the most, and then you create a metric and have a monitor for that specific thing, but there's always something new to go wrong, right?
Yeah.
So we are right at about time. So I wanted to ask you all for one parting bit of wisdom, like as people are starting to think about like how we design our systems, what reliability means. I know we've already mentioned simplicity, but like, what's one thing that folks should take away as they leave Dash?
I'd say you got to challenge your assumptions about your architecture and what will happen when things fail. Understanding the failure modes of all the different pieces within your system and what you do to recover is important from a thinking perspective, and you can design pieces to help with that. But then you need to actually exercise that. So what does happen when this particular server has this happen, or the CPU load spikes? Because we found things that didn't fail like we expected to. We actually tried chaos engineering.
Nice.
I'd say if things seem overly complex, they probably are. Ask yourself why. You know, like if it's over-engineered, was this somebody else's version of job security or you know, a vanity project or whatever? But those things are what kill you in the end. So I'm a big fan of why does it have to be so complex? You know?
I agree with all of those things. I'd also say like pay attention to your on-call and alerts. Like things that wake you up or tend to be like poor customer experiences. So, you know, you both win if you actually like clean that up. Like you go to sleep and your customer has a much better time with your product. The same thing with, you know, not like really thinking hard about splitting things before you really need to.
Awesome.
Can I have one more?
Yeah.
You got to keep reliability as a like a first-class stakeholder, because your regular stakeholders are going to demand features. Right? We've probably all experienced this. That leads to tech debt and complexity and things that just get pushed, and then that makes recovery so much more difficult because you're not actually ready to recover those things, and it's so hard to argue for that because there's no direct value to the stakeholders or the people who are like, you know, if they're paying their team, or, you know, depending on how your teams are set up and the contracts and so forth. So it's really hard to argue for that, to actually get that in there. Because the alternative, you know, when you do it right, no one ever knows about it, right? But when you don't, then something fails, and it's a big thing.
Awesome. Well, thank you. We are at time. That said, panelists are here. We'll hang out for a bit, so I know plenty of folks probably have questions. Feel free to come on up and ask questions of the panelists. We're just going to be hanging out, and I hope you've enjoyed Dash and have safe travels to wherever you're going from here. Thanks.
Thank you.